Example 7, second fundamental theorem of calculus. So we're trying to take the derivative. We're trying to take the derivative with respect to x of this integral here. So first of all, we have to make sure that this is in the right form to use the second fundamental theorem of calculus. So the second fundamental theorem of calculus states that if we take the derivative with respect to x of some integral from some constant a to some function x of f of t dt, that is going to be equal to f of x. And we already went through the explanation or the proof for that. So first of all, do we have the constant for the lower limit of integration? Yes. Do we have x as the function for the upper limit of integration? Yes. Do we have f of t? Yes, f of t right here. And then is it dt? And it is. So we have everything. So f of t is equal to the square root of t squared plus 1. So we can apply the second fundamental theorem of calculus, which if f of t is this, then f of x must be equal to the square root of x squared plus 1. Thus, this is equal to f of x, which is equal to the square root of x squared plus 1. So that would be the answer to the derivative of this integral with respect to x. Let's look at another one of these. Let's look at example 8. Okay, so if we look at example 8, all right, so they want us to take the derivative of this integral. Okay, so again, the second fundamental theorem of calculus states if you have the derivative with respect to x of some integral, with the lower limit being a constant, the upper limit being the function x of f of t dt, then that is equal to f of x. So we have the lower limit, that's a constant, but notice that the upper limit is x cubed. So that's going to be a problem. We do have f of t is equal to the cosine of t. So the first thing we have to do, we have to let u equal x cubed. Thus, the derivative of u with respect to x is equal to 3x squared. Okay, and if we look at our problem here, I'm going to take the derivative with respect to x of the integral from pi halves to x cubed cosine of t dt. Now, the first thing I'm going to do, okay, the derivative with respect to x, I'm going to replace x cubed with u. So I'm going to make that u. Okay, then I've got cosine t dt. And then notice here that I can make this du equals 3x squared dx by multiplying both sides by dx. And then I can say, okay, dx is equal to 3 is equal to du over 3x squared. So now what I'm going to do, I'm going to take the derivative, I'm going to replace dx with du 3x squared. And then notice here I can multiply the numerator and the denominator by 3x squared. So now I have 3x squared d over du, because these cancel out. And then the integral from a to u, cosine of t dt. And now here, this is the same as this. The only difference is this is dx, this is du. This is x, this is u. So this is going to be equal to this 3x squared, that would still be out in front. And instead of being equal to f of x, this is going to be equal to f of u. Where if f of t is cosine of t, then f of u must be equal to cosine of u. So now I have 3x squared cosine of u, where u is x cubed. So this is going to be 3x squared cosine x cubed. That would be our answer for that one.